Alright, welcome to the first flipped classroom. We've just finished Unit 2, which was quadratic relations and properties, and we're moving into quadratic expressions, where our big learning goals are to be able to interpret, solve questions related to quadratic relations. And you'll know that you've met your learning goals if you can use problem-solving skills to create and solve an equation that involves binomial expressions. So let's continue on. If you've gotten and really truly understand what's going on in this unit, then here's 4 questions that you should be able to answer at the end of all of this. Suppose the radius of a circle is x plus 2 and the height is 3x. Write a simplified expression for the volume of the cylinder. The area of a rectangular garden can be expressed as x squared plus 7x plus 10. Find the expression for the length and width of the garden. And if the area is 40 meters squared, what is the length and width? And so on and so forth. So I leave these for you guys to read. But again, excellent evidence if you can do these questions, that it indicates that you understand and have a pretty good understanding of quadratic expressions. Moving on, our first lesson here will be focused on multiplying binomials, and we can start by looking at our learning goals for this lesson itself. You should be able to explain the difference between a monomial, binomial, and trinomial, expand and simplify secondary polynomial expressions using a variety of tools or methods. And here, just to expand on that, you, by the end of this lesson, should be able to expand and simplify expressions similar to these ones here. And I'm going to show you the basics of how to get there. So here, we've got some review problems from grade 9. I encourage you at this point to pause the video and maybe take 2 or 3 minutes to do these, and this will hopefully refresh your memory on what you remember from grade 9 and what you need to know for this lesson. Alright, let's do this. So the 2 multiplies the x, that's 2x. We've got 2 multiplies the 4 is plus 2 times 4 is 8. Expanding this, 3 times 9 minus x, 3 times minus 27. 3 times minus x is going to be minus 3x. Continuing on, we've got 3x times x. Well, the x's, we've got 2 of them, so this turns into 3x squared. 3x times the plus 2 turns into plus 6, because 2 times 3 is 6. And we've got the x on the outside. 5x times 5x is going to be 5 times 5 is 25. X times the x is x squared. 5x times plus 1 is plus 5x. Again, these are skills which you'll be using in this lesson. Just to go through some key terms of what we've got in this unit, in this lesson itself. A term is a number of variable or the product of numbers and the variables. For example, and one thing I noticed with this software is that any time I've got an x squared, it's converted it down to a larger number, which isn't supposed to happen. So this is 2, 2x, 2xy, 2x squared, y, z, and that's a term. A monomial is an algebraic expression containing only one term. So all of these things here would be examples of monomials. A binomial, just like a bike, has 2 wheels. A binomial is an algebraic expression containing 2 unlike terms. Unlike meaning that they can't be combined. So x plus 3, 2x plus y, 2x squared minus y are considered unlike terms. If we were to consider x plus 3x, they can be combined. That would not be an example of a binomial. A trinomial would just be an algebraic expression with 3 terms. They kind of extend this a little bit more and they say it's a polynomial, which is something that we could get into a bit further later on. Coefficient would be the number or constant in a term. So whenever we've got something like minus 2xy, that minus 2 in the front is called the coefficient. So what we learned in the last unit is that there's 3 forms of a quadratic equation. There's the standard form, the factored form, and the vertex form. And the one thing which I tried pushing was the idea that this unit and the next units are all about converting between these. So what we're going to learn in this unit is how do we go from factored form to standard form. And the other one that we're going to look at is how to go from vertex form to standard form. And there's reasons for wanting to do that. Remember, the big goal in the end is to be able to look at some problems, interpret them, and solve them. And being able to convert between these forms is important. So here's our first example. We've got expand and simplify these binomials, and they're multiplying each other. And I'm going to encourage you to think of this here as being a number. So instead of it being x plus 2, what if it was just an n there, and then we've got x plus 3 on the outside? Well, then the n would multiply the x, and the n would multiply the 3, and this would be equal to nx plus 3n. And we can think of the same thing as happening up here, which would be this x plus 2 multiplies the x, so we'd have x times x plus 2. And we've got this whole thing again, and it would multiply the 3. We got the plus 3 x plus 2. So really what's happened is that whole bracket, this whole binomial, multiplied each the x and the 3, which is what's happening here. And now what we can do is we can expand x times x, these monomial times binomial, that's x squared. X times 2 is plus 2x, plus 3 times x is plus 3x, and 3 times 2 is plus 6. So now what we've done is we've expanded, but we need to simplify by collecting these like terms down here. So x squared, the 2x plus the 3x turns into 5x, and we've got plus 6. But just like in math, there's multiple ways of doing things. So if you didn't like that method, I'm going to show you two more methods which you may find more favorable. And this one here is called the FOIL method. And it's called the FOIL method because we got first terms, outside terms, inside terms, and then we've got last terms. And I'm going to explain what happens here in a moment. The x and the x are the first terms of these binomials, so they multiply. So that would be equal to x times x is x squared. We've got the outside terms. This x and this 3 here are on the outside, so they multiply each other. So that's plus 3x. Now we do the inside terms. Well, this is the 2 is on the inside and x is on the inside, so these multiply, plus 2x. And the outside terms, well, if this binomial is here, this is the outside term, this is the outside term. So the 2 and the 3 is 2 times 3 is plus 6. So we've expanded, and now we need to simplify, collect like terms. X squared, 3x plus 2x is plus 5x plus 6. This is my, I guess, out of the 3 options, this is my second favorite, but it does have its limitations. The third and final one is what I call the couples method. And the way I look at this is, it's like two couples are going to a dinner party and they're going to meet each other. This couple is going to meet this couple. Well, this person meets this person, so there's x squared. This person meets this person, plus 3x. This person meets this person, plus 2x. And this person meets this one, and it doesn't make any kind of sense that this couples would shake hands or meet each other because they already know each other. And it's the same result as FOIL. The only difference is that when we're using a couples method, you can extend this further to, say, trinomials times trinomials, whereas FOIL method is restricted to just binomials. Math is not a spectator sport, so here I've got 3 questions, which I encourage you to pause the video for a few minutes and try these on your own, and then I'm going to take them up. Now that I've given you a few minutes to take a look at these questions, we're going to take them up. So let's try and start to expand and simplify these questions. X times x is equal to x squared. X times 2 is plus 2x. this 1 times x is plus x, and we got this 1 times the 2, which is plus 2, and this is going to be equal to x squared plus 2 plus the 1 is going to be 3x plus 2. X times x is equal to x squared. X times the minus 5 is going to be minus 5x. 4 times the x is going to be plus 4x. And the 4 times the minus 5 is minus 20. Collect like terms. I've tried to give examples where they mix up the plus and minus signs just to make sure there's no misconceptions about what happens, because a common misconception is somewhere around here the minuses or pluses start to get mixed up, and there are mistakes that are made. Minus 5 plus 4 is minus x or minus 1, but because there's an x with it, it's just minus 1x. We don't need to have the 1. X times x is equal to x squared. X times minus 4 is minus 4x. Minus 3 times the x is minus 3x. And minus 3 times minus 4 is plus 12. Collect like terms. X squared minus 4 minus 3 is minus 7x. And we've got the 12 on the end. So this is how I've shown you to expand and simplify with 3 examples. If you're really keen and you've kind of noticed that there is actually a shortcut that's going on with these situations where we've got x plus a times x plus b, what we could actually do is we could add those two numbers, the a and the b, to get this middle term next to the x, and we can multiply the numbers at the end to get the ab at the very end. So when we look at this, we could expand it out. We know that this is already x squared plus 2x plus 3x plus 6. And notice here when we collect these terms, the 2 plus the 3 turns into the 5x. But is there a way that we could just jump right to the end? And there is, specifically when it's x plus a times x plus b. So let's look at this one. If we were going to do it, x squared, 10 plus minus 2 is 8. That's plus 8x. 10 times minus 2 is minus 20. This one at the bottom, x squared minus 5 minus 4 is minus 9x. And plus 20. Again, this is, when I do these things, I do it in my head. Notice that for this question here, the shortcut doesn't work. And that's why you need to know both methods, and the shortcut won't always work in all cases. So this would be equal to 3x squared. 3x times minus 2 is minus 6x. And here we've got 4y times x is plus 4xy. 4 times minus 2, 4y times minus 2 is minus 8y. And notice that we can't collect these terms any further because xy, that's x. We can't do anything more. We're done. That concludes this lesson. You've got some classwork homework questions here, which you can do. Again, with anything, practice makes perfect, and I'm always here to support you and answer any questions that you may have as you go through these questions. Thanks for watching.